Hello and welcome to class number 11 in my Bash scripting series. In this particular class, what we're going to do is take a look at data streams. More specifically, we're going to take a look at standard input, standard output, as well as standard error. But what exactly are those things? Well, let's just dive into the lesson and I'll tell you all about it. Data streams allow us to control where normal output goes as well as where errors are printed. And it even allows us to accept input from the user as well. The concepts that I'm going to be teaching you guys in this particular lesson are very important, and they're not just related to Bash scripting, although it's a very important concept for scripting as well. What we're going to go over is actually something that's very important Linux-wide. But before we see some example scripts that utilize data streams, we should first define what the data streams are, how they're used, and then we could get into some examples of how we'd incorporate these into scripts. First of all, it's important to understand that there are three types of data streams. In fact, we've been using one of the three types of data streams over and over again in just about every video in the series. Specifically, we've been using standard output. For example, the ls command. We've been using the ls command quite a bit in the series, and that's actually another example of standard output. Whenever we execute a command and the results of that command are printed onto the screen, what we've just seen is standard output. Standard output is, well, output. It's output that is printed to the screen. But the simplest way to remember standard output is that when we execute a command and we see the results, that's standard output. Now specifically, standard output is output that is printed to the screen that doesn't constitute an error. So for example, if I was going to list the contents of a non-existent directory, then that might look like standard output. That's actually standard error, and we'll get into the distinction later, and we'll also see some examples of why this is even important in the first place. Now, one way that we could easily tell the difference here is by typing echo and then $? If you recall from a previous lesson, that gives us the exit code of the previous command that we've run. And in this case, we're getting a non-zero exit code, so that's our indication that the command failed. A failed command printing output, well, that's standard error. On the other hand, if I was to do something like this right here, just echo hello world, and then we'll check the return code for that one, we get an exit code of 0. That command was successful. So hello world was printed to standard output, and the output from the ls not exist directory, the non-existent directory, where it says no such file or directory, that was standard error. Now, I've mentioned that there's actually three different types of data streams, but before we get into the third type, we should make sure that we have a firm handle on the two that we've gone over so far. So what I'm going to do is give you guys another example, and this one is going to show both standard output and also standard error. After we run the example command, I'll show you why the distinction between standard output and standard error is actually important, or at least very useful. So what I'm going to do is run the find command. A full walkthrough of the find command is beyond the scope of this entire series. I do have a video though about the find command on the YouTube channel, but essentially the find command allows you to find files or directories on the file system. You could give it search criteria, and then what it'll do is show you a list of every file or folder that meets that criteria. What I'm going to do is I'm going to start my search in the etc directory. And specifically what I want it to do is return every object that is a file. So I'll press enter, and we get a long listing of output here. We have a lot of files that are inside the etc directory, and I'm not kidding here. As you can see, there's a bunch of them. But I guess you could say the find command actually worked, right? I mean, I was searching for everything that contains a file within the etc directory, and I do indeed see results right here, a listing of files that are in that directory. But what's actually important about this example command is that it printed both standard output as well as standard error. If I scroll up, and actually I don't even have to really scroll up because I see an error right here, but there's going to be a few of these. Most of the time it looks like it was successful, but we have another permission denied error right here. And I'm not going to go ahead and read through all of that right there, but you get the idea. We have output that is valid here, among output that is invalid, so this file exists right here. But this directory, the find command was not able to enter that directory because the user that I'm actually logged in as right now does not have permission to view the contents of that directory. Now, if I was to use sudo with the find command, then I'll probably not receive any errors at all. After all, that would run the command as root, and root has access to everything. But since I didn't use sudo, my user does not have access to everything within the etc directory, so therefore, some of the directories, well, I just can't see what's inside of those directories, and neither can the find command because it was executed as my user, and as a result of that, the find command is limited to the permissions of my user as well. But anyway, a line shown here that's actually giving me a valid result, for example, the etc shadow file, that's standard output. But if a line contains an error message, that's actually standard error. Now, let's go through another example of the find command, and this time, I'm going to show you how to actually distinguish between standard output and standard error with this command. And the way that I'm going to do this is actually not specific to the find command, but we'll get into that later. Anyway, just like before, I will type the find command, and I will also begin my search in the etc directory. And yet again, I'm going to search for everything that is of type file. But here's where we're going to actually diverge from the previous example. I'm going to type 2 greater than, and then /dev/null. I'll press enter, and what do you think is going to happen? Now check this out. I don't see a single error in the list of output here, in the list of files. I don't see a single error at all, and actually there are no errors printed at all whatsoever. So does this mean then that I magically have access to everything because of that dev null thing that I typed in, and now I can see everything there is to see? Well, actually, no. The command is actually not any different at all. So for example, we can see that I have a non-zero exit code here. So that command was not successful, but I didn't see any errors though. And here's why that's the case. Right here, I have a redirect. Every now and then, we might want to redirect text into a file or maybe just move it somewhere else. So using a greater than symbol, and you've seen this before, is a great way to redirect something, maybe text, to a file. It's something that you'll be using a lot. But specifically, I'm actually redirecting anything that's a 2 into dev null. And dev null, if you didn't already know, is a special place on a Linux file system, and everything that you copy or move into that particular place will be completely wiped out. You could think of dev null as a black hole. Anything that's moved or copied into it is never seen from nor heard from again. So actually what I'm doing with this command is I'm instructing it to send any output that constitutes standard error to dev null. Now I'm not telling it to do anything specific with standard output, so any line that is a valid line, standard output, will be printed, but every line that constitutes an error, standard error, is going to be sent to dev null instead of being shown on the screen, which is why we didn't see any errors in the list. It's not that there weren't any errors, there were. The command is still doing the same thing. It's just that we're hiding the output, that standard error. Maybe I'm just not really caring about that. I want to see a list of all the files that I can access, and maybe I really don't care about the ones that I can't. And that could be a valid use case where you might want to differentiate standard error from standard output. You just want to send standard error somewhere else. Now let's do a quick experiment here. And what I'm going to do is remove the 2 and just redirect everything to dev null. Let's see what happens. Well, I see a bunch of errors here. I see nothing pertaining to standard output, but what I'm seeing is everything that is standard error. And here's why that's the case. Now, when I said I was going to redirect everything into dev null, well, that's not really what I was doing. And I knew that. I knew that everything wouldn't be sent to dev null, but what this does send to dev null is standard output. Since I didn't tell it to send standard error anywhere in particular, then standard error prints out. We see it on the screen right here. We have 5 error messages that constitute standard error. But everything that was not standard error was sent to dev null. So maybe I want to find all of the files that I can't access, because maybe that's an error. Maybe I should be able to access everything, and I want to find everything that I can't access so I could take action on that. That could be a valid example of a command like this. Now, if I was to add 1 to this command, what's going to happen here? Well, let's find out. It's exactly the same as the previous example. So here's what the number means. 1 constitutes standard output, and 2 designates standard error. If I was to not include the 1, then 1 is actually implied. You don't have to type 1 when you're going to redirect standard output. If you don't specify what you want to redirect, then the shell is going to assume that you want to redirect standard output specifically. So therefore, having a single greater than sign like this, or even a 1 followed by the greater than sign, those symbols are both the same. And in fact, if I was actually writing this out to a file, for example, this is going to overwrite the entire file because, well, I'm actually redirecting standard output into the file, but I'm not telling it where to send standard error. So if I press enter, I actually see the errors on the screen because, again, I didn't tell the shell where to send the error messages. I only referenced standard output with the 1 right here when I ran that command. So if I cat out the contents of file.txt, it contains every line that constitutes standard output. So quick refresher here. Standard output is everything that is printed to the screen that is not an error. Standard error represents something that is printed to the screen that is an error. Standard output is designated by a 1. Standard error is designated by a 2. So in a script or in a command, we can actually send standard output and standard error to different places. Now you might ask, why would this be useful in a script? Let's say, for example, you have a script and it's processing some data, and if there's any data that it can't access, or there's some kind of error while it tries to, process some data, you might want to let somebody know that there was a problem. So if we detect that standard error occurred, we want to let someone know about that because maybe we have to address that and fix it. So we might have standard output go to a log file, and then maybe standard error go to a different log file. Maybe standard error will be emailed to somebody who needs to take a look at that. There's all kinds of examples as far as why you might want to differentiate between the two. Now, before we move on with another example of how to redirect these separately, I'm going to give you an example of how to redirect both into a particular place. And we do that by typing an ampersand right here, which actually means that we want to address both standard output and standard error. We want to send both at the same time to another place. And because I have a single greater than symbol here, it's going to wipe out the file. If I wanted to append, I would include 2 greater than symbols. But anyway, let's press enter. And we see nothing on the screen. We won't see standard error. We won't see standard output. We see nothing because, again, we're telling the interpreter to send both standard output and standard error to another place, in this case, file.txt. And as you can see, file.txt now includes both standard output as well as standard error. So let's go ahead and expand on this example again, and I'll show you yet another scenario where we are sending standard error to one particular place and then standard output somewhere else. And I will again use the find command because this is probably the easiest way to teach you guys what data streams actually are. We'll get into a scripting example here very shortly, but let's go ahead and check out this example. So again, I'll use the find command against the etc directory. We'll look for files again. And then what I'm going to do is redirect 1, or standard output, and I'm going to redirect that into another file. This time, I'll just call it, findresults.txt. I think that's good enough. And then for standard error, what I want to do is send that to another place. And I will call this finderrors.txt. So this is literally going to split out standard output and standard error from the find command. We should see nothing on the screen at all because it's sending both things to a particular place, and we just won't see that because we're redirecting that. So as I suspected, we see nothing. And if I go ahead and cat out the find results file, we see all the lines inside that file that are actually standard output lines. And underneath finderrors.txt, we have the error messages right here. And this is an example of why this might be useful. So if you just assume for a moment that what I'm doing is copying error messages into an error log and successful messages into a success log, maybe I'm actually going to store that information in var log, which is a typical place in Linux for log files, then that would mean that I could create a script that is actually going to behave like a script does in production. This is very common. You want the errors to go one place and you want standard output to go somewhere else. That's what you want to do. You want to differentiate those things, especially because that allows you as the administrator to have a list of the problems or the errors. So that way you don't have to go through all the other results to find what you need to fix. You know what you have to fix because all the errors are in one place. Now, as an aside, I didn't actually have to put the 1 right here because, again, standard output is implied if you don't specify anything. So the number 1 and then the greater than symbol is, of course, standard output, and that represents standard output as well. All right, so let's see an example that actually utilizes this concept inside of a script. And to do this, what I'm going to do is update our universal updater script, the one that we've been working on in a few videos now. So what I'll do is run sudo. If you recall, in a previous lesson, we moved our updater into the user local bin directory, and we also set it up to be owned by root. And since I'm not logged in as root, I'll either need to switch to root or use sudo in order to edit a file that I don't own. So I'll use nano yet again, and the file, the script is at user, local, bin, and then update. And there it is. So what I'm going to do is actually make some modifications to this script. And once I've done that, I'll explain exactly what I'm attempting to do. All right, so I finished updating the script. Let's go ahead and take a look at it. So the first thing that I did was I've added 2 additional variables, log file and error log. The release file was already something that we were checking. That's basically the text file that we're looking in to try to find out which distribution this particular script is being run on anytime it does execute. But log file and error log, those are actually new because we want to actually send the update messages to updater.log, and then we want to send all the failures to updater_errors.log, both underneath the var log directory. But how do we know inside the script if something was successful or not? Well, right here, we have sudo pacman-syu. Again, if you are using Arch Linux, then that is the update command for that distribution. And directly after that, what we're doing is we're testing to see what the exit code actually is. We want to know, is the exit code not equal to 0? So anything that is non-zero is actually an error. So we want to know, was there an error? If there was, then what we're going to do is echo this statement right here. And then I went ahead and did the same thing right here. I'm checking the error code, trying to see if it's 0. And if it's not, I want to actually print an error like I'm doing right here, but there's something missing that I forgot to add because this script is actually not redirecting anything anywhere. So we definitely need to add something to the script so that it's actually able to send output to the appropriate place. So I'll add it right here, and I'll type number 1 and then 2 greater than symbols. Reason being, I want to actually append, not overwrite. And 1 represents standard output. I want to send standard output to the log file. And then I'll actually redirect standard error somewhere else. And specifically what I will do is send standard error to the error log. And then down here, I will actually do the same thing. So right here, I will type 2 greater than symbols next to 1 for standard output again. Let's send that to the log file. And let's send standard error over to the error log. We'll do the same thing right here, and you might be thinking that this is incredibly redundant, and you're right, but we'll get to that. And you can see right here, we're checking the exit code for the sudo apt dist upgrade command, but we should also check that with the sudo apt update command as well. So again, I'll add even more redundancy, why not? Just be more for us to fix later. And there we go. We have the newest version of our update script right here. Let's go ahead and actually run it. I want to know, does this even work? Do I have any typos? I'm recording this right now without having tested this yet, so there could be a typo. But you know what? It happens. It's okay if there are. We'll fix it. Let's go ahead and just run it and see what happens. And right now we're getting some permission denied errors. Now to keep it simple, what I'm going to do is switch over to root because that is actually why we're having this problem. We have a lot of different file redirects going on here, some of which only root can access. So as root, what I'll do is run /user/local/bin and then update and see whether or not we have any errors. Hopefully everything works. Now what's interesting is that something is happening here, but I'm not seeing any output at all. None. And the reason for this is because it's actually updating in the background. But one issue is when it gets to the dist upgrade part, it's actually waiting for me to type Y and then press enter to continue. That's something that we would probably want to avoid. So what I'm going to do is just Control C to break out. Let's go ahead and edit our script. We'll fix that problem. And what we'll do to fix it is we will actually add -y as an option to sudo apt dist upgrade to make it assume yes. And this is actually very common. When you are scripting, you really want to avoid any prompts at all. You don't want anyone to be prompted for anything because there might not actually be someone at the server watching it. And the whole point of automation is to, well, automate. It's hard to automate something if somebody has to babysit a script. We definitely don't want that. So I added -y, so let's save it. Switch back to root. And we will run the update script. Let's see what happens. So right now, it's actually hung up. But what's interesting here is that it should actually be working. I'll open up a new tab here. And then what I'll do is execute tail-f against var log updater.log. We can actually see that it's doing something. The tail-f command, what that does is it watches a text file in almost real time. It just updates over and over again. So as new information is being added to the log file, as the script is actually doing some actual work, it's going to show what's going on in the log file as it's being written to. And this allows us to watch it because over here, we're sending both standard error and standard output to their own individual files, which means we're not going to see them here or any output here because all the output is being sent somewhere else. But we can actually watch a log file in real time. So right now it's actually downloading updates. Since I gave it the -y option, it's actually going to install patches and updates for my system. This is going to take a minute, so I will be right back as soon as this is finished. All right, so the script actually didn't work, but it's not because of the script. Something happened to my internet connection, believe it or not. And to show that, I'll go ahead and print out the contents of the error log. And as you see here, it wasn't able to fetch some of the updates, so it never actually completed. But I'm actually kind of glad that this happened because what you're seeing right here are actual errors being shown in an error log. Now, back as my normal user, let's check out the script and I'll go over it one more time and then I'll show you another example. And here we have the script. So real quick, I have the log file variable that just contains a path and a file name to where I want actual log messages to be sent over to. We have the error log. That's where I want the errors to be sent over to. And we have our first if statement here. We've gone over this in a previous video, but specifically what I'm doing here is I am sending standard output and standard error to their respective log files. And I'm actually checking the exit code to see whether or not an error has occurred, basically whether or not the exit code is anything but 0. And if it's true that the exit code is not equal to 0, it will print this line right here. And then I'm going to repeat similar logic down here. There's going to be a lot of redundancy that we will fix later. But for right now, we are successful in the sense that we were able to differentiate standard output and standard error and modify our script to handle those scenarios differently. That's pretty cool. So what I'm going to do right now is write another script, and this one is going to be fresh. I've gone over standard output and standard error, but at the beginning of the video, I actually mentioned that there are 3 different types of data streams. So what's the third? Well, actually, the third type of data stream in a Linux system is going to be standard input. This is when we are actually accepting information from a user. We want the user to input something. That's going to be standard input. So here's an example of that. What I'm going to do is create a call to action. I want the user to do something. But what do I want them to do? Well, I guess a simple example is I will have them enter their name. And now that I have an instruction right there that will print to the screen, we can go ahead and take input from the user, but how would we do that? Well, what we will do is we will use read, and then we'll create a variable. I'll call it my name. So the my name variable will be equal to whatever the user enters in. That's what read is allowing us to do. We're reading information from the user and we are storing it in a variable, and this variable is called my name. Next, what I'll do is echo your name is my name, just like that, and we'll close it out. It's literally that simple. So let's go ahead and run it. Please enter your name. Okay, I'll go ahead and do that. And it says your name is Jay. Well, that's what I entered. So the script works. What you have just seen is an example of standard input. It may not be as popular as standard output and standard error, but it is important to know what it is, and now you do. Standard input is, well, input. If you ever want your user to enter in something, and you want to capture whatever they type into a variable, then that's standard input, and read is an example of standard input. Anyway, hopefully this video has helped you to not only understand what data streams are, but also why they could be very useful in scripts. Now, make sure you hang on to our updater script for now. We're going to use it again in the next video when we discuss functions. So there you go. I hope you guys enjoyed this particular lesson, and if you did, please, as always, click that like button to let YouTube know that you found this content helpful. I would really appreciate that. Anyway, whenever you are ready to move on to the next lesson, you can go ahead and do so, and I'll see you in that lesson as soon as you're ready. In the meantime, thanks as always for watching this particular video, and I'll see you again very soon.